Welcome back, everybody, for another deep dive. And today, we're going somewhere pretty wild.
Yeah.
Buckle up, because we're diving into the world of quantum physics
Right.
and climate science.
Yeah. So not your typical climate change.
Right. Not the usual
Yeah.
climate change debate. We're going way deeper.
Deeper than that. So we've got this academic thesis.
Okay.
It's called Quantum Enhanced Climate Modeling and the Impact of Human Activity on Global Systems.
That's right.
I mean, that right there
It's quite a title.
is a mouthful.
Yeah.
So get ready
It really sets the stage for
some seriously mind-bending stuff.
kind of complex topics we're going to be grappling with.
We're talking quantum principles to model how things like nuclear explosions
Right.
and burning fossil fuels actually impact our climate.
Huge.
I'm not going to lie.
Yeah.
When I first saw this, I thought,
I know.
okay, science fiction. Yep. It's not, though.
Yeah, no.
It's real science.
It's real.
And it's pretty mind-blowing.
Get ready
Yeah.
for quantum feedback loops, gravitational shifts.
Yes.
Are you telling me
I'm
that
proud.
explosions can actually change gravity?
Well, not explosions in the way you might be picturing,
Okay.
you know, like a
Like a firework.
stick of dynamite or something.
Yeah.
Think more about massive energy releases.
Okay.
Right? Like really big events
Okay.
that can slightly warp the fabric of space-time itself.
Okay.
That's how Einstein described it in
Yeah.
his theory of relativity.
I am so out of my depth right now.
But it's fascinating stuff.
But I am very intrigued.
It really is.
Okay.
So these changes in space-time,
Yeah.
they might be tiny,
Yeah.
but they can still influence things like
Okay.
how our atmosphere and oceans circulate.
Okay. How can something as small and as strange as quantum physics?
That's the really interesting thing about this.
Yeah.
Even though quantum events happen at a microscopic level,
Yeah.
they can set off a chain reaction
Right.
with huge consequences for the climate.
So tiny little things, big consequences.
Exactly.
Got it.
It's all because of these things,
Okay.
called quantum feedback loops.
Feedback loops.
Oh,
Okay,
it's
now,
clever.
has you ever
Yes.
thought about
How
how,
are those exactly?
like a domino effect,
Okay,
but with subatomic particles?
I like that.
So picture this,
Yeah.
a nuclear detonation
Okay,
that releases an enormous amount of energy,
right.
right?
Yeah.
Well, that energy interacts with the atmosphere at a quantum level
Oh, wow.
and actually changes how chemical reactions and energy transfers happen.
So it's like a chain reaction, but on a super tiny scale.
Precisely.
Yeah.
And the result,
Yeah.
significant changes in temperature, pressure, and even the composition of our atmosphere.
Okay.
Just to give me...
Give me an example, a concrete example.
Yeah,
Consider the ozone layer,
Right.
you know, that protective layer
of course. Yeah.
that shields us from harmful radiation.
Yeah, well,
Pretty important.
there's an equation to
What?
describe how it gets depleted.
Okay.
And it includes factors like ozone and nitrogen oxide concentrations.
Mm-hmm.
But here's the crazy part.
All right.
It also includes quantum radiation.
Hold on. There's quantum radiation in that equation.
You heard that right.
Okay.
And this quantum radiation,
Yeah.
which gets released after events like nuclear detonations,
Okay.
directly affects how quickly the ozone layer breaks down.
I see where the mind-bending part comes in.
Right.
We're talking subatomic particles released by a nuclear explosion
Yeah.
impacting the ozone layer.
It's kind of terrifying, to be honest.
It is a sobering thought,
Oh,
and it gets even weirder.
no.
Quantum effects like tunneling and entanglement,
Okay.
which sound like they belong in a sci-fi novel,
Right.
also influence how fast these chemical reactions occur.
Yeah.
Think of tunneling like a particle phasing through a wall like a ghost.
Okay.
And entanglement is like two particles linked together no matter how far apart they are.
So spooky action at a distance.
Yeah.
Okay.
I got it.
Wild stuff.
Okay, so these quantum events are so small.
Yeah, that's
How can we be sure they really matter
a great question.
when we're talking about something as massive?
And one that
Researchers
researchers,
are actively exploring.
yeah.
What we're finding is that
Okay.
while the individual effects might be small,
Okay.
they can get amplified through these quantum feedback loops.
So it's like that butterfly effect.
Exactly.
Okay.
Small changes can have big consequences.
So even though these are happening
Right.
at a tiny scale, the cumulative impact could be huge.
Precisely.
Okay.
And this is where the idea of quantum-enhanced climate models comes in.
That's where these new climate
Yeah, traditional climate models,
Yeah.
while incredibly powerful,
Yeah.
often struggle to capture the nuances
Right.
of these quantum effects.
So they're like climate models on steroids.
You could say that.
Okay.
They're like the next generation
Can you give me the ELI 5 version
of climate models.
of how they actually work?
Yeah, think of it like a network of points,
Okay.
each one representing a different climate variable,
Got it.
like temperature or pressure.
Okay.
Energy flows between these points,
Okay.
but the flow is governed by quantum mechanics.
Okay. So the pipes are like changing shape
It's like a complex plumbing system
all the time.
where the pipes are constantly changing shape and size
Yeah.
based on these tiny quantum events.
Okay. So we're essentially using quantum mechanics to predict the climate.
It's pretty incredible.
It sounds incredibly futuristic.
It is.
The thesis also mentions something about these models being used to simulate specific scenarios.
Yeah. No, they're
Okay, can you tell me more about that?
incredibly versatile.
Yeah.
The thesis outlines a simulation framework
Okay.
specifically designed to model the global climate's response
Okay.
to things like nuclear detonations and the burning of fossil fuels.
Did the world end?
Well, thankfully, no.
Okay. Give me the dramatic version.
Let's start with the nuclear detonations.
Okay.
The researchers set up a mini model of our atmosphere
Okay.
and focused on key points representing temperature, pressure, and ozone levels.
Okay, so those were like the most important variables, the key players.
Okay.
And then they simulated the detonation
Oh, my God.
and watched what happened.
Okay.
Immediately after the detonation,
Yeah.
there were massive temperature spikes
Okay.
and huge shifts in atmospheric pressure.
So shock waves.
Imagine shock waves rippling through the quantum model.
Wow, that's intense.
It's pretty dramatic.
What about long-term impacts?
Right.
That's where fossil fuel burning comes in, right?
Exactly.
Okay.
Those simulations focused on the gradual buildup.
Of greenhouse gases like CO2 and methane over time.
Over time.
They took a baseline climate
Okay.
and then significantly increased emissions to see what would happen.
I'm guessing the results weren't pretty.
Unfortunately, you're right.
Okay.
The simulations showed a concerning acceleration
Okay.
in the rate of global warming
Yeah.
as a direct result of those increased emissions.
This is a lot to take in
Cheers.
quantum feedback loops, gravitational shifts,
Still lots of process.
and now these alarming simulation results.
Yeah.
I am a little overwhelmed.
It underscores just how interconnected our climate system is.
Yeah.
And the importance of understanding both the short-term impacts
Right.
of events like nuclear detonations and the long-term trends
Yeah.
driven by things like fossil fuel emissions.
Okay. I think we've covered a lot of ground already.
We have.
Let's take a break here
Yeah, let's take a breather.
and come back to explore the implications of all this
Absolutely.
and what it means for the future of climate science.
I'm looking forward to that.
Okay.
It's a fascinating topic.
We'll be right back.
Yeah. So, we've looked at these simulations and the models behind them.
Yeah.
And they offer a really powerful new lens for peering into the future of our climate.
Like a crystal ball.
Kind of, yeah. We're starting to see,
Yeah.
in very concrete terms,
Yeah.
how human actions
Right.
can have subtle but significant consequences for the planet.
It's almost like we've been missing this whole
Yeah.
layer of reality this whole time.
It's like we've been looking at the climate
Yeah.
with one eye closed.
And now we've opened both eyes.
Now we're seeing the full picture.
Yeah. It's exciting and a bit scary at the same time.
I know. It's a
Yeah.
lot to take in.
But the thesis goes even further, right?
It does.
It talks about how quantum machine learning
Yes.
could enhance our predictive abilities even more.
That's right.
So we're not even
We're scratching the surface.
at the peak.
Yeah. Think about it this way.
Okay.
Traditional climate models
Yeah.
use complex equations to represent different parts of the climate system.
Right. So they're kind of like simplified versions of the real
rules and
world.
approximations.
Right.
But quantum machine learning
Yeah.
can analyze massive amounts of climate data
Okay.
and actually identify patterns and relationships
So it's like it can see
that those traditional models might miss.
things that we can't.
Exactly.
Yeah.
It's like giving those models a major intelligence boost.
So we're teaching these models to understand the underlying quantum mechanics driving climate change.
We're giving them the tools to see the quantum world
Wow.
and how it affects the climate.
Okay, so how does that work?
Well, the thesis focuses on something called a
Practically.
quantum enhanced regression model.
Okay, that is a mouthful.
I know it's a bit of a jargony term,
Yeah.
but basically it's an algorithm
Okay.
that can use information like greenhouse gas concentrations to predict future climate variables like temperature,
So these models are learning how to read the subtle signs
That's a great way to put it.
of how human activities are influencing the climate.
Yeah, they're learning
This really fundamental.
to connect the dots between the quantum world and the climate we experience.
That's wild.
It is pretty amazing.
What could these quantum-enhanced models do?
Well, one of the most exciting things is that they can help us make more accurate predictions
Okay.
about how our climate will respond to different scenarios.
Like, what if we did this?
Imagine being able to test out
Yeah.
the impact of various policy decisions
Yeah.
or technological advancements on the climate
Yeah.
before they even happen.
That would be incredible.
It would be a game changer
Yeah.
for climate policy and decision making.
Okay, can we circle back for a second?
Sure.
What have we learned so far?
Well, I think the key takeaway
Yeah.
is that we can't ignore the quantum world any longer when it comes to understanding and predicting our climate.
We can't just look at the big things.
Exactly.
Yeah.
For too long, climate science has mainly focused on large-scale events.
Right.
But this research shows that those quantum effects,
Yeah.
as tiny as they are,
Yeah.
play a huge role in shaping our climate.
It's like we thought we knew how it all worked.
It's a complete paradigm shift.
Then we zoom in and it's like a
Yeah.
whole other set of rules.
It's like we've been trying to solve a puzzle
Yeah.
without realizing that some of the pieces are invisible to the naked eye.
And those pieces are really important.
And it turns out those invisible pieces can have a big impact.
So quantum feedback loops, gravitational shifts,
Yes.
quantum enhanced models, these are all...
All these things
of course.
are shaping our climate in ways we're only beginning to understand.
We've talked about nuclear detonations and fossil fuels.
Right.
What other human activities might GMB?
That's one of the most exciting things about this field.
Quantum enhanced models.
There's so much potential for further research.
Okay. Like what?
Well, we could use these models to explore
Yeah.
the impact of deforestation,
Okay.
different geoengineering strategies,
Okay.
or even the incredibly complex role that ocean currents play in the climate system.
So it's like we're opening a Pandora's box
Yeah, it's like a whole new world
of quantum climate mystery.
of possibilities has opened up.
Yeah.
And another crucial area for research is testing these theoretical models
Yeah.
against real-world climate data.
Right. We need to make sure
That's essential for making sure our predictions are accurate
that they work.
and for refining the models even further.
So this is for scientists?
This is a call to action.
But what does this mean for the average person?
It's a reminder
Yeah.
that we live on an incredibly interconnected planet
Right.
where even the smallest actions
Yeah.
can have ripple effects.
Like the butterfly effect again?
Exactly.
Yeah.
It underscores that each of us
Yeah.
has a role to play in mitigating climate change,
Even if it's just like recycling.
whether it's through individual choices
Yeah.
or advocating for policy changes.
I like that.
We all have a part to play.
Because I think a lot of people feel like,
Yeah, it's easy to feel helpless
yeah.
when we hear about the climate crisis.
Yeah, but this research suggests that we can
But this research suggests that we can make a real difference,
make a difference.
even at a personal level.
Okay.
And it highlights the power of science
Yeah.
to help us solve complex problems.
Yeah.
Through research, innovation, and collaboration,
Yeah.
we can unlock the full potential of quantum climate science.
That's inspiring, right? Yes. And create a more sustainable future.
Absolutely.
I think we've had a wild ride.
It's been a fascinating journey.
That's deep dive, for sure. We've gone from...
We've gone from the mind-boggling world of quantum mechanics
Yeah, quantum mechanics.
to the future of climate modeling.
It's inspiring to see how science
It's truly fascinating how these two fields are intersecting
is helping us understand our planet on a deeper level.
and shaping our understanding of the climate.
Okay, I have one last question for you.
Okay, shoot.
If quantum physics can influence our climate
Yeah.
in these unexpected ways,
Mm-hmm.
what other hidden forces might be shaping our world
That's a great question.
that we haven't even begun to explore?
And I think it's one that'll keep scientists busy
Yeah.
for generations to come.
Who knows what's out there?
Who knows what other mind-blowing connections we'll find
Right.
between the quantum world and our everyday reality.
It's humbling and empowering at the same time.
It is.
To think about how much
It's both humbling and
I
empowering
still don't know.
to realize that we're still just scratching the surface of what we know.
Yeah.
There's so much more to discover.
And that's what makes science so exciting.
Absolutely.
Yeah.
In a world that often feels defined by what we already know,
Right?
it's thrilling to realize that there are still so many mysteries out there
Yeah.
waiting to be unraveled.
You know, it's almost like we've stepped into an alternate reality where science fiction is becoming science fact.
Right. It's wild.
I mean, who would have thought that the fate of our planet
Yeah.
could be so intertwined with this bizarre world of quantum mechanics?
It's a truly remarkable convergence of disciplines.
Yeah.
And what's so exciting is that we're really just at the beginning of this exploration.
Right. We've just opened the door.
Yeah, there's so many avenues of research yet to be pursued.
It makes you wonder, like, what other seemingly unrelated fields
Yeah.
might hold the key to unlocking even more climate mysteries.
Exactly.
I mean, if quantum physics can play such a crucial role,
Yeah.
what other surprises might be out there?
That's the beauty of science.
Yeah.
It's a constant process of discovery and reevaluation.
Right. We could be totally wrong about something.
We might find connections
Yeah.
in the most unexpected places.
Like, what do you think?
Well, perhaps there are insights from biology,
Okay.
information theory, or even art that could shed new light on climate change.
That's a fascinating thought.
It's all connected.
I think what's really struck me today
Yeah.
is how this research challenges our assumptions about cause and effect.
Right. It's not just about...
It's not just about big, obvious actions having predictable consequences.
Yeah, sometimes the smallest, most unassuming events
Right.
can set off a chain reaction
Yeah.
with global repercussions.
It's humbling.
It's a humbling reminder
Yeah.
that we're all part of an incredibly complex and interconnected system.
Our actions, no matter how small,
Right.
have the potential to influence the delicate balance of our planet.
Our actions matter.
And that should empower us
Yeah, it should empower us
to make more conscious decisions.
to make more conscious and informed choices.
Yeah. I think that's a really powerful message
I agree.
to leave our listeners with.
It's a message of hope.
Yeah. This deep dive has certainly given me a lot to think about.
Me too.
It's awe-inspiring and a bit daunting at the same time.
Yeah, it's both.
To realize just how much we still don't know
It is.
about our planet and the forces that shape it.
But that sense of wonder and curiosity
Yeah.
is what drives scientific progress.
That's what keeps us going.
It's what motivates us to keep asking questions,
Yeah.
keep exploring, and keep searching for solutions.
To all the challenges we face.
Exactly.
So to our listeners out there, we encourage you
Yeah.
to embrace that sense of wonder.
Keep learning.
Keep learning, keep questioning,
Keep questioning.
and keep pushing the boundaries
To keep pushing the boundaries of what's possible.
of what's possible.
Because who knows?
Because who knows?
Maybe your curiosity will lead to the next breakthrough
Right. Your curiosity could change the world.
that helps us create a more sustainable future.
That's a great note to end on.
It is.
Well, it's been a pleasure diving deep with you today.
The pleasure was all mine.
Until next time,
Yeah, until next time.
keep exploring the quantum world
Keep exploring.
and all the mysteries it holds.
And all the mysteries it holds.
Thanks for joining us
Yeah, thanks for listening, everyone.
on this incredible journey through the intersection of quantum physics and climate science.
It's been a wild ride.
We'll catch you on the next deep dive.